Okay, now that I have all the Skippy commands I need, I'm going to need to write some code around these Skippy commands in order to automate my whole setup. Now, if you're a RF or electrical engineer not so used to software, then the good news is that today, with all the different large language models and AI out there, it's pretty easy to get some basic scripts going without much programming knowledge. So today I'm going to be using Microsoft Copilot in order to help me generate the framework where I insert the Skippy commands to do this experiment. So I'll tab out of here and open up my browser where I have Copilot launched, and I'm going to ask it to help me write some Python code. I don't trust these AI tools to generate Skippy code today. I find they don't do a great job, but for doing generic Python, I think it's very good. So I'll ask, please generate a Python script using PyVisa, which is a communication library, to do the instrument control. To control a signal generator and analyzer, and a for loop to sweep the signal generator's base from -180 to +180 degrees in 1 degree steps, measuring power with the analyzer at every step. The phase setting and measured power results should be written to a CSV file. Print out the power and phase value at each step in their for loop. So let's see what it comes up with. Here we go. I'm starting to generate some code. And so I can see here, this looks pretty reasonable to me at a glance. I'll copy all this and come into my preferred code editor. I am using VS Code here. Create a new file and paste this in here. You can text that it's a Python file. I have already installed PyVisa previously. And now we need to modify this for our specific measurement. Okay, the first thing we need to do is to update the Visa addresses for both of the instruments. I'm going to come into Keysight Connection Expert and grab the Visa address. I added these instruments previously here. There we go, VXG and the UXA inserted right here. And now we need to insert the instrument setup. Say instrument setup right here. We'll insert both the VXG and the UXA setup right here. I have the setup over here in the notepad on my other screen. So I'll start with the vector signal generator, the VXG's Skippy commands. Here they are. You'll notice here that these are the plain text commands, and we need to wrap these inside of the specific syntax needed by PyVisa. So I'll highlight these here and hit Control-H in my editor. And I'm going to use search for the \n, which is a new line command. And I'm going to replace that with \n on the previous line, comma parenthesis, colon parenthesis, and on the new line, insert vxg.write, parenthesis, colon, highlight this, and make sure that's working. I have regular expressions enabled, step through, and I can see here I'm inserting now the proper command for all of these. I'll close off the ones at the very end, the beginning here. Such, now we have all the Skippy commands. I'll do something very similar for the signal analyzer. You have here all the signal analyzer Skippy commands. And I will again come through here and search for the new line. Instead of VXG, I'll say UXA, and step through and update them all like this. Ensure that I close off the first and last here. Okay, it's close define and replace menu. And let's take a look at these commands, because some of these should be sitting inside of the measurement loop, while some of them should be sitting here in the setup portion of it. And one thing to note here is that these OPC question marks should be changed to queries. So anywhere you see a question mark, you should treat that as a query. And I know this command I manually looked up. I can remove this n argument here. One thing I want to note here is that this command here is going to have an output that we have to modify a little bit. So let's take a look at the output. We can use Keysight Connection Expert and the interactive I/O monitor in order to send this command and see what the output looks like. You see the output of this command, the response looks something like this. It is a string with some commas in it. And so we are interested in this first value, which is the total channel power. So why don't we ask the LLM how to parse this properly so we get this as a double value in our code instead. So I'll pop back over to my browser and ask it, provide a Python example for parsing a string of comma separated values and retrieving the first value as a double. So we can see here a string very similar to one we're working with. We're going to use split and float of the first indexed value, the index 0 value. So I'm going to copy this over here because we'll be using this in our code. And I'll insert it here.